Unfortunately, I've already done this video and I'm on the second one because I did not save it. Super frustrated, but anyways, here we go. All right, so function operations and compositions. Okay, so function operations. You got your four basic function operations. Okay, you've got adding, subtracting, dividing, and multiplying. Okay, so it is very similar to your four basic operations in math, right? So that's one way to remember that. Okay, and then on the back, on this second page, you've got compositions of functions, and essentially what that is a function within a function. All right, so we'll get to that. It is a little bit more complicated, but that is also something we'll get into. All right, now let's get this thing to stop doing that. Okay. All right, so function operations. This is just notation. All right, so it is a little bit weird when you see both of these in parentheses, but essentially all it is you are taking f of x and you're adding it to a g of x. Okay, and that's all it is. Okay, I know it's a little the notation's a little bit different, but you're literally just taking two functions and you're adding them. Okay, and I'll go ahead and tell you these two are going to end up just being combining like terms. Okay, so here we are, very similar. You're taking f of x, you're subtracting g of x. Okay, on this one, okay, you may also see it written as like this. Okay, so f g, but notice it's a closed hole. Okay, of x. When it's a closed hole, it's your standard multiplication. Okay, but when we, just to show you, when we get to operations, you'll see this like open hole. Okay, that means it's a composition. It's f of g of x. Okay, so f of g of x. But here, this would be f times g of x. Okay, so just don't get too confused with the difference between those two symbols. All right, so when we get there, and you see this symbol over here, that is going to represent a composition. All right, so anyways, this is f times g of x. All right, so it's f of x and then times g of x. Okay, over here you've got f of x, and then you are dividing g of x. Okay, all right. So let's go ahead and jump in and do these examples. All right. So for each of these problems, all right, you've got an f of x, you've got a g of x, and you've got an h of x. So you've got three different functions, and we'll kind of do different things with each. Okay. First, let's go ahead and kind of remind ourselves about domain. The domain of this right here. Okay, so f of x, there's no restrictions. Okay, a lot of the restrictions that we've been dealing with are when if we have a square root, then we take out the ones that are give us values. We take out the ones that will give us a negative inside the square root. Okay, if we've got a rational, we take out the value or values that will give us a 0 on the bottom. So far in this class, those are the two that we've dealt with that have different domains. All right, but on this one, there's no restrictions. There's no square root. There's no dividing by a value. Okay, so this is just all real numbers. Okay, this one here, notice there is the square root. So there's two different ways to think about it. One is to take out the values that would give you a negative number. Okay, or you can think about it as a domain is everything that will not give you a negative number. Okay, so what I like to do is probably the best way to think about this is just, what values of x plus 3 inside the square root, what values will give me a value that is greater, okay, that gives me a value greater than or equal to 0, because that would be acceptable. Okay, so this is actually going to be your domain. You can subtract by 3, subtract 3, so x is greater than or equal to negative 3. Okay, so that's your domain here. Okay, and then over here, no restrictions. X is everything in the real number system. Okay, or a real number set. Okay, so find each of the following, then find the domain. All right, so f plus g of x. So what I'm doing, just as a reminder, is I'm taking f of x, and I'm just going to add it to g of x. That is all we're doing, okay? Like I said, in the examples where we're adding and subtracting, it's very similar to just combining like terms, okay? So that's all we're doing there. All right, so with the result of this, okay? So f of x plus g of x. I'm just taking f of x and I'm going to add it to this. So this one's going to be relatively simple. I'm just going to do x squared minus 2x, and then I'm going to add the square root of x plus 3. And that's it, okay? I'm taking those two functions and I'm adding them together. There's no like terms because of that square root, okay? Right, this is a squared term, this is just an x term, and this is a square root of x term, okay? And then square root of 3. So there's no like terms in this particular one, so you just leave it exactly like that. Now for the domain, since we have this square root of x plus 3, okay, since we have that, we can't actually plug in anything that is in this, our domain remains as this, right? I can't have a negative value in here, and so these values of x will give me something that's greater than a negative value, okay? So these are the ones that are still going to remain to be good to go, all right? Anything, you know, I can't plug in -4, I can't plug in -5, because in this, I'm going to get an undefined, all right? So anyways, we keep this domain because we have that same restriction as we did over here. Okay? F minus h of x. So I'm taking f of x and I'm subtracting h of x. Okay? So let's go ahead and write this one. Now I will say the ones where you're subtracting, these are probably going to end up being a little bit harder, but not too much. But the only reason that it's a little bit harder is because of the subtracting part. Okay? Remember, subtracting and combining things like that when you're subtracting expressions is a little bit more difficult because you've got the negatives and everything like that. All right, so let's go ahead and do it though. F, okay, so I'm going to go ahead and write f of x. So we got x squared minus 2x. That's the first one. Okay, and then I'm subtracting, right, that's my f of x. I'm subtracting this. Okay, now make sure you write it in parentheses because, again, those negatives are a little bit of a pain sometimes. Okay, so we're combining like terms, and I noticed that these two are like terms. Okay, so I've got x squared and then negative 2x squared. Okay, but I've got x squared minus a negative. Okay, so this ends up being x squared plus 2x, so this is going to be 3x squared. All right, and then I've got minus 2x, but minus nothing because there's no other like terms, so I'm still just minus 2x. Okay, and then from here I'm subtracting a 1. Okay, so if I wanted to put something in here, I can kind of like sneak a 0 into this parentheses. So 0 minus 1, that's going to give me a minus 1 here. Okay, and so that is my function for f minus h of x. Okay, so that's kind of the reason why we have that notation, is to think about this entire thing as a function. Right, this is the one function. This happens to be the function f minus h of x, given that these are my originals. Okay, with the domain, no restrictions. There's no one quick check, right? There's no rationals and there's no square roots. Okay, so within the realm of this class so far, those are the only ones where our domain would be restricted, and so we're good on that. Okay, f times g of x. So with multiplying, right, you've either got FOIL or you've got distributing. So that's probably what you're going to end up doing. Let's just see what ends up happening with f and g. Okay, so f of x times g of x. Okay, so I've got x squared minus 2x, and I'm multiplying g of x. Okay, so my g of x is up here. It's the square root of x plus 3. Okay, so now what we can kind of do here is, in order to multiply, we want to kind of look at our terms. So I've got two terms here, and then one term here. So when I've got a two term and a one term, I've got to distribute the one term. Okay, that's how I like to think about it. Okay, so if it was two terms and two terms that we're multiplying, we've got to use the box method or FOIL in order to multiply those out. Okay, but for this particular one, since I've got a one term to a two term, I'm going to distribute those. Okay, so I've got x squared and then times the square root of x plus 3. Okay, and then I've got a minus in between. Okay, minus in between, and then I distribute those. So I got 2x and then the square times the square root of x plus 3 there. Okay? Now, kind of depending on the problem, maybe it's good practice for us to go ahead and write this out and go ahead and simplify it. But the truth is, you could leave it as this if there's no real specification on how to simplify it. Okay, so it just kind of depends there. But this is a perfectly fine answer as my function. Okay, but it's good practice for us to distribute them because we may, that kind of thing may show up at some point. All right, so anyways, the domain, because of these again, okay, because I have this square root of x plus 3, because of that, I'm going to have to, again, keep that same domain because we have that square root restriction again. Okay, h divided by f of x, okay, so this is just going to be h of x divided by f of x, all right? So that's exactly what we're going to write. And on this one, you don't have to even simplify at all. There's really nothing you can simplify. We could do long division, but no use in doing that. All right? At least not for this problem. Okay, so that's going to be my function. Okay, and again, where I'm getting those is I'm taking my h of x. Okay, so I just literally wrote h of x up top, and then on the bottom, f of x right here. Okay? So I just put that over that. Now for the domain of this one, okay, this is a little bit of a tough domain, so I'm going to leave some space here for it. Domain work. Okay, notice I've got a rational function, right? So those are the two kind of most common in our class so far, square root and then the rational. So since this is a rational, well, what's the one number we can't divide by? We can't divide by 0. So whatever values of 0, okay, whatever values of x make this 0, I've got to take those values out of the domain. Okay, again, I can't divide by 0, right? The logic is I can't divide by 0. So whatever values of x give me 0 here, I've got to take them out of the domain because those are not allowed. Okay, because I'm going to get an undefined. Okay, so what I like to do is just to set, this x squared minus 2x equal to 0. Okay, and whatever values of x give me a 0 here, I'm going to take those out of the domain. I'm just going to write set builder and put not equals this, not equals this. Okay, now as kind of a quick reminder how we solve for these. Okay, the best way to do it is to, especially when you have multiple terms, is we've got to get this something that looks like a times b equals 0. Okay, because the truth is, when we have this, there's two options. There's two options to make this true. Either A is 0 or B is 0. Okay? So it seems like a simple concept, right? If A is not 0, then B would have to be 0. If B was not 0, then A would have to be 0. So those are the only two ways that this would make a true statement. So because of that, factoring actually really helps us here in this domain. So that's how we solve for these when we don't have like a more simple way of doing it, okay? If you had, if this was just x squared minus 5, this would be relatively simple. We move the 5 over, we take the square root, but we don't have that. Okay, so anyways, we want to get something, right? If it helps, you can put parentheses, something times something equals 0. Right now, we don't have that. We have x squared, we have something minus something equals 0. I want something times something equals 0, and that's what factoring is good for. Okay, so these both have a factor of x, so I'm going to go ahead and pull, that's the thing I'm going to factor out. So I've got x times, okay, x minus 2. Okay, now I have that something times something. I've got x times x minus 2, and I did not have that before. Okay, so the reason we have that is now we can split it, right? It's x equals 0. That's one thing that will make this true. Okay, so x is 0. That's 1. Okay, and then x minus 2 is equal to 0. This is just one more step. We add 2. We add 2. We get x is 2. Okay, so those are the two pieces that I will take out of the domain. Okay, those are the two pieces I'll take out of the domain. All right, and just to double check, let's go ahead and plug in 0 here, and just check that the whole thing would be 0, right? We've got 0 squared, well, that's 0. Okay, 0 squared, that's 0, minus 2 times 0, that's 0. So 0 minus 0, the whole thing would get me 0. So that's a value I can't have on the bottom. Let's check 2. Okay, 2 squared, that's 4. Okay, minus 2 times 2. Okay, that's 4 as well. So 4 minus 4, that whole thing would give me 0 as well. So I can't have that because it would be dividing by 0. Okay, so for my domain, x such that x can't be either of these two things. So x can't be 0, and then x cannot be 2. And that's my domain. All right? Now, so for evaluating, okay? Evaluating each of the following. So I'm just going to pull the one that we already have the function for, as opposed to having to find each of these, okay? So I'm gonna do my easy one. Just to give you a heads up, we would have to find what h minus g of x is in order to get what h of g minus 3 is, okay? And same over here, we'd have to find what f divided by, I should have said h minus g of x. I don't know if I did or not. But over here, we'd have to find f divided by h of x first, and then we would plug in the negative 2 to evaluate. Okay? So one thing over here that might be confusing is the notation. This is not the function times 1, right? Or this is not h minus g times 3. What this is this function, right? So f plus g of 1, right? So look at the similarities here, right? This is f plus g of x. Well, we know what f plus g of x is, and that was just f of x plus g of x. So we took f of x and we added it to g of x. Okay, but the only difference here is now instead of x, I'm writing 1. So I'm taking this function up here, right? And instead of x, I'm just going to write 1 throughout. So instead of x here, I'm writing 1, 1, 1, and then I evaluate. Okay, so and again, the reason is this is f plus g of x. This is f plus g of 1. Okay, so it's the same. We're taking that function and plugging in 1. Okay, so here we go, 1 squared. All right, again up here, 1 squared minus 2 times 1. Okay, plus the square root of 1 plus 3. Okay, and we evaluate 1 minus 2. Okay, plus the square root of 4. I'll go ahead and do the square root of 4. Well, really it doesn't matter. We can do 1 minus 2, okay, negative 1, okay, and then plus 2. Okay, so negative 1 plus 2, going to all of that give me positive 1. Okay, so that's evaluating an operation. All right? Okay, compositions. Let's go ahead and flip to the back. Okay, so with compositions, okay, these are a little bit more complicated, but once you get the hang of it and kind of see it, it's all about seeing it, right? If you can see what the concept is, the math part is not necessarily difficult, okay? But when the output of one function becomes the input of a second function. So, essentially what you're doing, okay, I want you to look at this right here. Let's focus on this. Okay, and let's think about what we normally have when we have a function f. When we normally have something in the parentheses, typically it's x, okay, right? F is a function of x, okay? So we're inputting x into a function, and then we get out a value, right? And that typically, the way we think about it is we input x, and we get out a y, okay? And so that's what this is, right? F of x represents an output, okay? And then x represents the input. Okay, so think about it. What's in parentheses this time, though? Okay, well, what's in the parentheses this time is a g of x. Okay, but what's the input of g of x? Well, so we're inputting x, and this is an output, but now that output is an input for f. Okay, so kind of a visual way to think about it is this. Okay, for my initial input, I'm inputting x. Okay, so first I input x into g. Okay, and then I get an output of g of x, but then I re-input it, right? So it's I'm inputting x into g, I get an output, which is g of x, but now I'm taking that output and I'm inputting it again into f. Okay, and then I get out f of g of x. Okay, and so something I said in my first Ingenious video that I happened to lose Well, it's like you're putting an input into two different functions, kind of like you would put your clothes into the washer, and then you got to take them out, and then you re-input them into the dryer, right? So you get clean clothes. So you got dirty clothes as your initial input, and then after putting it into two different things, you've got the output of clean clothes. I don't know. I thought that was ingenious the first time. I might as well say it again. I totally came up with it on the fly last time. I don't know how, but that video is gone. Okay. So anyways, you initial input X, you put it into G, you get an output, and that output is now an input into the second function, and you get out another value. Okay. So one thing to think about is when you have that initial value as a real number, right? Not just X, you're going to get an actual number out for the end all output. Okay, and let's look at this one. Okay, we start from the inside, right? My input is going to be X again. This time I put it into the function of F because that's the kind of more center, right? You start at the center. And then you're going to get out an F of X. And then you're re-putting that value in to G, okay? And then you get out G of F of X, okay? So let's look at a little bit of a more concrete example. Okay? All right, so first though, I want to go ahead and change these to like a table. Okay? But what this is, it's going to be easier to think about it in table form in my opinion. Okay? What this is it's saying f of x is these values. Okay? But these are like the inputs and outputs. Okay? Is kind of what this set is, right? So what it's saying is it's saying when you input the two, right? This is like your x and your y. It's like coordinates, sort of. Okay, so when you input 2, you're getting out for f of x. You're getting out 3. When you input -1, you're getting out 5. When you input 3, you're getting out -1. So in order to write this in table form, okay, you're inputting an x, you're getting out an f of x. Inputting 3, you're inputting 2, you're getting out 3. Inputting -1, you're getting out 5. Inputting 3, you're getting out -1. Inputting 0, you're getting out 0. That's your table for f of x. G of x, the table for g of x. Okay, you're inputting 0, getting out 2. Inputting 3, getting out 0. Inputting -1, getting out -1. Okay, so we're going to reference this table for these particular questions because it's going to help us a little bit. Okay, so this is the notation. Again, that little symbol just means you're inputting g of x into f of x. All right, so what we're doing here, and I like to rewrite it. I don't necessarily like this notation because I can't see which is inside which. Okay, but I'm going to rewrite it f of g of 3. Okay, so we got to go to the centermost function first. Okay, so let's do that. I just want to focus on what g of 3 is, right? Remember what I said is when I actually have a value here, right? When I actually start with a real number as an input, you're going to get a real number out. Okay, so our answer is going to be a number here. All right, so g of 3. Okay, so I'm inputting 3 into g. Okay, so I'm going to g and I'm inputting 3. Okay, so when we input 3, we're getting out 0. Okay, so this value is 0 now. So I now have f of 0. All right, because g of 3, well, what is g of 3? That's 0, right? G 3, 0, right? Inputting 3, getting out 0. Okay, now we have f of 0. Well, so now let's go to our table of f of x. When I'm inputting 0, I get out 0. So my end-all answer here is 0. Okay, next one. I'm just going quick. I know you can, rewind or whatnot. Okay, so g of f of 0. All right, g of f of 0. Okay, let's see how this one works out. So I start with f of 0. Okay, so I'm going to my table right here. Okay, when I look at f of 0, right, I start with the centermost. I get out 0. Okay, so now it's g of 0. Well, what happens when I plug in 0 for x into my g? I get out a 2. Okay, so there we go. Okay, so it's you take a value, you're putting it into one function, and you take that new value, that new output, and put it into another function. Okay, take in your dirty clothes, washer. Now you have wet clothes, then you're putting it into the dryer. Now you've got clean clothes. Okay? On this next one, okay, and then you guys can figure out that. On this next one, so now when we actually have a real expression, okay, an actual equation, all right? Let's see what it looks like with that, okay, because this is like the numbers, you're like given the outputs and you kind of find it from there, but this is more, maybe a little bit more theoretical, but we're still inputting values and inputting something into a function. Inputting one function into another, really is what I should say. Okay, so f of x, this is equal to 2x squared minus 1, g of x, x plus 3. Okay, find f of g of x. Okay, so let's go ahead and do it. Okay, f of g of x. Okay, now here's how I want you to think about this. We are putting g of x, whatever g of x is, okay, here's g of x. We are putting that in, right, and what normally goes here? Well, it normally says like f of x, right? Well, we're going to take g of x, whatever it is, and we're going to input it everywhere I see this, right? So look at what we're doing, right? It's f in parentheses of g of x. So I'm taking this function, I'm taking that, and I'm inputting it into here. Okay, I'm going to erase this later, so I'm writing it kind of light. Okay, but I'm taking that function, g of x, and I'm inputting it in where I see x, right? Because that's what we normally do. If it's like f of 2, we're going to write 2 everywhere I see an x. But this time, I'm going to write g of x everywhere I see an x. Well, what is g of x? G of x is x plus 3. So I'm going to write x plus 3 everywhere I see an x in this equation. Okay, so f of g of x. Here's what I like to do. Okay, I'm going to write my f function. Okay, I'm going to write the function, and every time I see an x, I'm just going to write a big parentheses. Okay, so I write, I'm just writing my f function. So f is 2 times x squared, okay, and then minus 1. That's my entire, I write my entire f function, but instead of x, I write a parentheses. Me personally, that's what I like to do. Now, I'm going to go and fill in those parentheses, okay? Well, because what's in those parentheses? Well, if it was just f of x, right, x is in those parentheses, but now I'm doing g of x, so it's x plus 3 is in those parentheses, okay? And so that would be really, that's a perfectly fine answer. You could simplify this if you wanted, all right? And maybe it's a good just time to do that because we haven't done a quadratic simplification in a while. Okay, so some side work here. We're just simplifying this part. Everything else kind of takes care of itself. So x plus 3 squared. Remember what that is that's x plus 3 times x plus 3. And remember how we simplify these? We've either got a FOIL or use the box method, okay? Or you can kind of think about it as distributing a little bit. But personally, I like the box method, so I'm going to go ahead and do the box method, x plus 3. X plus 3, I've got x squared, I've got 3x, 3x, and then 3 times 3 is 9. Remember what all I'm doing is I'm just multiplying each of these, so x times x gets me this, x times 3 gets me 3x, and then after that I add them, okay? And so for all of that, we'll go ahead and get x squared, and then plus 6x, all right, and then plus 9. Okay, so that's what I'm going to rewrite for this. So 2 times that, x squared plus 6x plus 9, and then after that minus 1. Okay, so I'm going to first distribute the 2, so 2x squared, and then plus 12x. All right, and then I'm going to combine some steps here. 2 times 9, 18. 18 minus 1. All right, so 17. All right, so that function right there is f of g of x. Okay, that is my f of g of x. All right. Okay. So we could also do it the other way around though. Okay, and I'll tell you this one's a little bit easier actually. Okay, so this is g of f of x. G of f of x. Okay, so I'm taking the function f of x, right? I'm taking the function this time, right? I'm taking the function f of x, and I'm inputting it into the other function. Okay, so everywhere I see an x, I'm going to write f of x. Okay, so in order to be consistent, I'm going to write that function g first, and instead of x, I'm going to write parentheses. That's what I like to do. If there was multiple, right? If there was multiple spots with x, you're going to have to write multiple parentheses. Okay? So parentheses here, well, what goes in the parentheses? F of x goes into that parentheses. So 2x squared minus 3. So the only evaluation we have to do here is combining like terms. So -1 plus 3, so it ends up being 2x squared, and then plus 2. Okay? And that's my function. Okay? Now, on this one, okay, I'm evaluating, just to show you, I'm evaluating g of f of x, but this time I'm evaluating it at -5. So this is my function, right? The only difference from here to here, right, is instead of x, I'm writing -5. So I'm inputting -5 into g of f of -5. So remember, when I'm inputting an actual value, I'm going to get out an actual value. Okay, so instead of -5 here, I'm writing, instead of x here, I'm writing -5. Okay, so for on this one, 2, okay, times -5 squared, all right? And then -5 squared is 25. 25 times 2, 50. 50 plus 2, 52. We got to use order of operations there, right? PEMDAS. Okay? All right, there's that one. I'll get you going on this one just to write it, okay? So we're at f of g of x, okay? Again, I like to rewrite it like this. I think it's way easier in this notation because I can see what's in the parentheses. Okay, so g of x here. Instead, I'm gonna just write f. I'm gonna just write the f of x function, and instead of x, I'm gonna write parentheses. Okay, and inside those initial parentheses, I'm writing g of x. So that's x minus 1 squared. Okay, and on this one, this particular one, right, we've got x minus 1 squared, that whole thing squared, but then I'm taking the square root, so that just is going to go back down to x minus 1. Okay, so that's your function on that one. All right, and then notice these two match up, so if I wanted to get this, instead of x, I'm writing 4 minus 1, so it's going to be 3. Okay, and I'll leave you to it for g of f of x. But it's the same process, right? You just write g, whatever g of x is, leave those parentheses where you have x, input the other function. Okay, and then to do one of these are really interesting problems. I'm going to do one of them. So there's multiple answers on these, okay? So like a lot of these are there's just multiple different ways to do it. Okay, and so what you're writing is, this time it gives you the composition, right? So it's saying that we have a g of x within an f of x here. So we've got to think about how we can leave it to where we can plug in g of x into an f of x. Okay, these are a little bit complicated. All right, you have to kind of reason through them. But again, there's multiple answers. I'm going to give you multiple answers just to show you how these would work. Okay, so I've got to think about like a big operation, like the overarching thing here for this f of x. Okay, and maybe what I do is I notice this operation of the square root, and I'm going to just forget about the rest of that. So I've got square root. Well, if I want to make my g of x this inside stuff, then that could work, right? And then I would just make my f of x this right here. Okay, so if I just make that my f of x just the square root of x, okay, well, remember that if I were to, rewrite it, I would kind of write, and this is separate, okay, it'd be square root of the parentheses. Well, what is in the parentheses for this, right? Well, I could put x squared plus 1. Okay, so that would be an example of one pair of an f and a g that would make an f of g of x. Another example is if you were to, I don't know, and you could probably come up with some more. Okay, but one example, maybe we could do square root of x plus 1. Maybe we enter that x plus 1 this time. Excuse me. And then we were to make the g of x. We can kind of think about what can I plug in to this, right? just this part to make it look like this. So what would I would have to plug in, right? And it's not that you're multiplying, right? It's that you're, instead of writing this, okay? So the blank one would kind of look like this: f of x square root that. Okay, what am I rewriting there? My g of x is what I would rewrite here, right? Because I'm taking out that x. What would I rewrite here to give me this? Well, that's going to be x squared. Okay, so that is round 2 of this video. But that's all I got. Okay, I'll leave you guys to it on this. But again, potential multiple answers on that. All right. Y'all have a great day. Take care.